All right, thanks everyone for coming. This is going to be a quick lightning type talk on Istio. Raise your hands if you've ever heard of Istio so far. Oh, more than I was expecting. How about people that are developing microservices? Okay, nice. So you probably realized microservices are actually very hard. Problems that used to be monolithic in nature, your problems tend to live in the heap. Now you've decoupled that. Problems that might be in a single monolithic heap are now spread across a large dependency graph of services. There's lots of benefits to microservices, of course, scaling, working with teams of teams, working independently on different parts of the application. But there's lots of challenges too. Historically, people that have been developing microservices have to deal with things like circuit breaking, where if I'm developing a microservice, I need to know how a cascading failure might happen if that service stops working or if a dependency stops working downstream. So think about it, if I have a user working on an application and there's 10 different microservices that are involved with sending a response back to the user, and I've heard like at Amazon there's up to 300 types of microservices that get involved in a single user request to like the Amazon cart. But say one of those microservices stop failing, how does that propagate down to the user? Do you have things like failback capabilities? How many milliseconds are you going to wait for the service to work? Are you caching local things inside your browser or inside a microservice if an end user downstream or if an end service downstream stops working? Things like policy enforcement, security, handling property files throughout these different types of applications. These are really hard problems to solve. And that's just to look at Netflix and Amazon, that they're probably at the extremes, of course, of the scale. Now, OpenShift is a great platform for developing microservices, but it's actually not a complete microservices platform. It gives you tons of capabilities out of the box. It gives you a whole logging stack that is aggregating all your logs with Elasticsearch and FluentD and Kibana. It's giving you things like service discovery, elasticity, so auto-scaling your application as new requests come in. Now you can do based around custom metrics, so things like certain number of concurrent users or other properties or features of the application. You can scale up and down on demand. You notice resilience is there's actually not an OpenShift logo there because we're actually talking about from a microservice perspective. So inside any Kubernetes-based platform, you have a thing called a replication controller or a replica set, and that's handling failed pods, right? So if a pod crashes, a new one spins right back up, does the same thing, and you're off and running, right? Well, no, really, because if we're in a microservices architecture, how does that failure affect everything downstream or upstream? So we still need to handle this inside our code. Of course, you can roll out pipelines. We have CI/CD pipelines that we give you to roll out new features and apps, and that's all great. But authentication, so we handle role-based access control for the actual platform itself and the objects you're creating, but not the actual application users. So think about things that have typically been done with SAML or OAuth or other web-based front ends. We don't really handle that for all the workflow throughout your whole request of your application. So there's lots of things that have been that you still need to account for. So something called bulkheading. That's basically where if a service downstream breaks, you might say, well, I'm only going to have 10 outstanding concurrent requests to that service. And so if I have 10 outstanding requests, well, what happens when in service C? Well, what happens when I have 30 requests that come into that? So once 10 are outstanding, 10 have failed, or they're hanging, or whatever, I'm actually going to start caching or having some other sort of dummy result set that gets returned back to a user. Tracing, so if an application service does fail, I need to find out where that failed, right? So if my user is getting a 500 error, which microservice failure is actually causing that error? So way back in the day, we used enterprise services buses to handle some of this stuff. And then back in 2012, 2013, Netflix became really popular for outsourcing a lot of the work that they've done over the years at Netflix to kind of create a large microservices architecture. There was things like Hystrix, which is a library that you embedded in your application to handle those types of bulkheading type requests like fault tolerance, circuit breaking. Zool which is basically a way to handle filters and process applications inside your application. Ribbon and Eureka are just load balancing platforms. Archaeus was a dynamic properties library. They worked really well, but there's lots of drawbacks to this approach. So the biggest drawback is all those things were Maven dependencies inside your Java application that you needed to handle. Every time you upgraded your app, you're actually now maintaining a large code base to do all this type of stuff. It actually gets pretty unwieldy at scale, because now every time you update your application, you're updating all those libraries back here. Oh. So every time you update your application, you're updating all these things inside your POM file. Another big drawback to this was it's not only language specific, but it's framework specific as well. So if you're doing things with Spring Boot, it might be different from another, if you're doing something with Vertex or something else. And this is largely just a Java. Netflix is mostly Java. So this is largely just a Java implementation. So if you're doing Go or Python, you really end up implementing a lot of these things yourself. So a lot nicer way than having all these embedded libraries inside your code was to embed it inside a proxy. Inside OpenShift, or really any Kubernetes platform, this becomes really convenient because every time you deploy an app, you can deploy a proxy with it. And inside of Istio, we actually use something called Envoy, which has been around for a while. It just got open sourced about a year or two ago. It came out of Lyft, so everything at Lyft uses Envoy. They're the main developers behind the Envoy proxy. So I haven't mentioned Istio yet, but everything if you notice in Kubernetes comes out of this kind of the nomenclature of sailing. So Kubernetes is the helmsman or ship's pilot. Istio is a sail. So when I define Istio, I actually say it's a control plane for managing a bunch of Envoy instances, a bunch of proxies. So it's a way to manage proxies at scale. But you'll often refer to this called as a service mesh, or a platform to manage and monitor your microservices. So it actually gets really powerful because when I have a proxy for my application inside the platform, I'm handling all the traffic that's coming in and out of my application. So it gets incredibly powerful in what you can do. So I can do things like service authentication, load balancing, circuit breaking, fine-grained routing. So I'll show you a demo, but when I do things like rollout canary deployments, if you use OpenShift, it's great because you can do canary deployments already out of the box, but it's based on a pod level. So if I wanted to roll out, say, 2% of my application traffic to my new application to test it out, I'd have to have 50 pods to get exactly 2%. But within Istio, I can get a little more fine-grained. It's collecting all my metrics of my application. It can handle things like service authentication, authorization. It can also inject faults. So I can say, which I'll demo to you at the end, I can actually say, well, my microservice has an SLA of 7 seconds. So I want to see what happens when this application can actually inject a 7-second delay inside my application and see how that responds to other applications downstream. So it's a really good way to test out your SLAs as well. The way it works with inside Kubernetes is it actually uses a platform adapter for Kubernetes. So I would say if you look at Istio across the board, most of the use cases or things you'll see around it are for Kubernetes, but it actually can be used for Docker, like plain Docker containers for using Console or Mesos. There's a Cloud Foundry plugin as well, I think. So it actually uses a platform agnostic model. One of the cool things about that is now we're seeing the model applied to virtual machines as well. So if you're using Istio to manage microservices inside OpenShift, inside Kubernetes, you can actually apply it to things that will still be running somewhere in a VM. Because we're not doing greenfield apps. We have lots of traditional apps that we're working with as well. So it's a way you can kind of plug in those, and it doesn't have to be just limited to what you're running inside of a container platform. The metrics flow, so this is really nice too. So Envoy's collecting all the metrics as far as how the requests and workflows are flowing into the system and out of the system. It can plug into Prometheus. Is anyone using Prometheus right now? It's eventually it'll be the default metric stack for OpenShift. It's really nice because it has a lot of pluggable adapters for existing technologies that are out there, and it's also really easy to plug in like your app-specific stuff. But it's first-class citizen inside of Istio, so it can collect all the metrics, forward them to Prometheus, and then you can display them with Grafana. You can make decisions and routing based around those metrics as well if you need to. Visibility and tracing. So one of the real nice things about Istio in general is kind of with a traditional Netflix OSS route, it was really difficult because not only did you have to build all those things in your application, but you also really had to have the domain knowledge of all the services downstream that you depend on. And with inside Istio, you really don't, because you can externalize all that logic inside Envoy. Maybe an operations person might need to know a little bit about Istio, but as a developer, you really don't. And that was another kind of drawback of kind of the Netflix OSS route, is the developers were then responsible for all of the microservices type of functionality that you need to build in, whereas now operations can kind of manage it through a centralized control plane. That's a snapshot of the Grafana dashboard with Prometheus kind of collecting all those metrics. Has anyone used Zipkin before? So Zipkin is a way to actually trace through microservices applications. So if you use like any of the proprietary stuff out there, like AppDynamics or New Relic, they have some similar capabilities. Zipkin's like an open source way to kind of trace down and see the whole workflow. You can build in some of this stuff with like Apache Camel or something as well to kind of collect request headers that are coming into your microservice and make sure that those requests propagate down so you can kind of track it. But Zipkin's an open source way to do that. Istio can feed into Zipkin, so you can kind of trace all your microservices down throughout the platform. Resiliency and testing. And so this is really cool. You can basically see how your microservice is going to react, or how your application is going to react when you inject specific delays into your application, just to make sure that it's going to, say you have that 7-second delay, make sure that the application is still going to work. You can also test different HTTP errors. So you can say, what if this microservice starts returning a 500 or a 404 or some sort of redirect? How is the application going to react to that? You can plug all those in as well, right through the Istio control plane. This is an example of doing a traffic split route. So if I'm a developer, maybe I'm rolling out a new feature, I can do something called a canary deployment. Canary deployment is when you, similar to blue-green, when you have a blue-green deployment, I have a new version of my application. This actually became really popular at Netflix. They call them red-black deployments if you read any of their stuff, just because those are their colors. But most other people in the industry call them blue-green. Blue-green's where you have a new version of your application and you want to test it in production. So you bring it up side by side, and then you test it manually before you change a pointer for the end users to actually to consume that application. Canary is same concept, but instead of like a binary version of it, you just start rolling out new traffic little by little, 1%, 2%. This is how Facebook deploys new features. So if you're on Facebook, you might get a new feature, and it might be one of your friends might see the feature, and then tomorrow you might see it, or a week later you might see it. Istio actually has a really cool thing too, which I won't have time to show, but it can actually mirror the traffic. So within a typical blue-green deployment, you'll bring up the second version in production. You'll start testing it manually before you change the pointer. But within Istio, you can actually mirror the traffic. So version 1 of your application, or the blue version of the application, is still handling all the live traffic. But version 2 is actually getting a copy of the traffic, so you can see how it reacts. Just to make sure everything's healthy, make sure the SLAs are all being met before you handle turning off the traffic. Traffic steering, so I'm actually going to demo this as well. So you can make specific requests for maybe, in this case, an iPhone user, but I guess if they'd be using Safari or some other request header, maybe there's a cookie or some other thing that you want different. So maybe all my Firefox users are going to go to one microservice, and all my Chrome users are going to go to some other microservice. I can start doing that based around all the request headers. One of the big pain points, this is actually my last slide before I demo. So one of the other real big pain points about using microservices at scale is kind of the certificate rotation aspect. So this is becoming a real big problem. So we've been working with a lot of different federal agencies around this. So we have very traditional, especially in government, we have very traditional ways that we get certificates. We generate a certificate signing request. We send it to some third party. They send us back a certificate that's signed by a known federal certificate authority or intermediate certificate authority. That's really difficult when you're doing microservices because, say I'm auto-scaling, right, and I've got two pods running, and now I've just spun up to 10. So how am I going to, where are those certificates coming from? Are they all going to use the same certificate? Is it going to be is all the traffic going to be just encrypted until the edge and then unencrypted? If you're using something cool like HashiCorp Vault, they actually do some things that are very similar. If you're using the same certificate, you do have limitations because now you don't really have any non-repudiation. So if something malicious does happen, how do I know which pod that was that caused the malicious thing downstream if they're all using the same certificate? So that becomes a problem that's just starting to get addressed now. Inside Istio, they actually have something called the Istio Certificate Authority. This used to be called Istio Auth. It's now called the Citadel. But now I can basically generate certificates on the fly and start mounting them into pods as my applications spike in traffic. So it gets pretty powerful on what you can do. In the new version of Istio 0.8, which is a long-term release that they just released on Thursday, Friday timeframe, this is all renamed to Citadel if you look at it. They also broke up the install into an a la carte install. So you don't need all these pieces if you want. You can just download or install just one of them. You might just want the certificate rotation aspect of it. I think this will be interesting as this whole space matures and as government processes kind of update with it, I think, just because this is a really hard problem in government right now. If you have all these microservices running all these different platforms, generating them in some sort of automated way is really kind of like one of the last miles I see to really big microservice adoption in federal. So demo time, I forgot to change that slide to TBD, but I'll show you a quick demo of Istio. So this is just their sample book application. I was actually going to show you a different demo, but all the APIs changed in 0.8, which just came out Thursday. So it actually just using the sample app for now. So this is an application that has several microservices. It has 3 different versions of the book reviews. So it has one that generates no stars, another one that generates black stars, and another one that generates red stars. So there are 3 different microservices. If I come inside, OpenShift, I can just see them running as different pods. I have 3 different versions right now of the application. So the way everything is managed right now inside of Istio, this is visual code, by the way, is basically by a YAML, unfortunately. There's not really a great kind of management tool around it yet. But this is a virtual service, so this can be used to manage different rules and routing-based rules. So in this case, I want to lock down to version 1 of my application, which is the no stars, but I want my user Jason to see version 2. So I can install a routing rule that does that. So this is right here. So I'm using a regex expression for all users that have user equals JSON in the cookie. If any user equals JSON in the cookie, then I'll go to version 2 of my application, which is the blue stars. If they don't, they'll default to going to the original 1-star version of it. Replace that. And so now when I refresh, all my users should just be getting this, which is the version 1 of my application, the reviews. But if I sign in here as Jason, then all blue stars, or I mean all the black stars. So this will be a good way for me to test my application. I can also inject the faults here. So in this case, I will inject a 7-second delay, and I'm going to test my, I'm still going to send JSON to the version 2, but I'm going to inject a 7-second delay here. So for 100% of my applications, they'll get a 7-second delay back to the rating service. We'll see how that behaves. I copy and paste these because if I do it live, then I'll make a lot of typos. Actually, I was at Summit and Michelle caught a bunch of typos I was making when I tried to do it live, so I don't do that anymore. So now I'll make a 7-second delay, and I'll actually open Firefox, or Chrome has a networking aspect here. So when I hit the page, you can see it's kind of hanging for 7 seconds. And I didn't get my review section. So there's something happened in my application that actually broke. If I open up, this is just the standard Chrome debug tools, but you can see there's roughly, it shows 6 seconds, so about 7 seconds delay here. And I'll close that back up. So there was something in my application that broke. So if I have an SLA, I know that now this might not be worthy of getting rolled to production. I didn't have to make any code changes or put anything specific to my application in that. This could be a Go app, this could be a Python app, this could be a Ruby app, what have you. So I'm going to delete that one. So instead of rolling back that fix, I'll roll forward. So I can do like a 50-50 split if I want to. Open this one up. So this is pretty simple. Just going to do a 50 split of traffic between my version 2 and version 3 of my application using these weighted average here, 50-50. I'm going to replace it, and I'll sign out, although it shouldn't matter. And they're using version 1, and then I hit version 3, which is should be the red star. So this will split 50-50 across. Then I can use that, and I can continue to roll them out little bit by little bit if I want to, until I verify that all my testing is good, and then I can kind of change the route rules as I want. But this is a really good way to kind of test applications. I wouldn't say that it's really production ready yet. It's definitely worth using in like dev, pre-prod. There's still a ways to go. We are going to ship it with OpenShift in 3.11, so probably in the fall. Some of the barriers to getting it production ready, I'd say right now, are one, there's still a security piece around it, so everything runs as privileged. So if you think about like the sidecar that's a proxy, all that needs, it's doing all of the IP tables magic to kind of make that happen. So that needs, if you're a Linux admin, it needs cap network admin. Basically, it's a network admin on the box right now. So there's some work being there to kind of get that working with least privilege. There's other things. It's using a lot of CRDs. Anyone know what a CRD is? It's basically a way in Kubernetes to extend the Kubernetes platform with any other type of application you want. There's a little bit of usability things with CRDs that are still being worked out. And overall, like bug testing and things like that are still, I'll be using it, just kind of playing around with it. There's still a few things that have to happen. But I do think that this is kind of the future of managing platforms or managing microservice platforms at scale with Kubernetes. And the community is working really fast. They have community calls. I was just on the one Thursday. There's a lot going on here. But yeah, I'd say we're probably about 6 months away from this being either GA'd with 1.0 or at least 4 months right now, just kind of working through those least privileged things and working through some of the documentation and some of that other stuff. But yeah, and we've got 3 minutes left, so any questions on Istio or kind of where you think it's going? Shoot.
Instead of IP tables, it should be firewall D.
I think it's still using IP tables. Yeah. I think it's still using IP tables. But either way, it needs network admin access right now to kind of manage all that. And right now, a lot of the focus is on minimally viable product. So least privilege is like the last thing that people look at. They're like, hey, let's get this out the door, and then let's make it secure. So yeah, so yeah, so Red Hat is a big contributor, but there's lots of other companies involved as well. Shoot.
With this being added to OpenShift 3.11, is that when you feel like it would be production ready, or is it something that would be independent?
That's a really good question. For all the community stuff I've seen is Linux-based right now. Windows firewalls are different. How they manage that. I know that with the Windows team, kind of working tangentially with that, a lot of the things that they're doing with like the kubelet and DNS proxy, the implementation level of it is a little different than on Linux. So I'm not 100% sure when this would run on Windows as well. Just kind of following the community and going to some of the community meetings, I don't see it as being something that's being actively tested right now compared to the Linux side of things. But as it matures, I'm sure it'll probably get a little bit more of the way there. I think for people running like .NET Core apps, they can run those on OpenShift or really any like Linux-based distro. .NET Core, they released at MS Build in Seattle a few weeks ago. They referenced or they mentioned .NET Core 3.0, which is actually going to be like the last mile for all the .NET Framework stuff. So basically, once that released, everything from .NET Framework will just be able to compile more or less into .NET Core. So at that point, unless you're running Windows-specific features, everything can run on a Linux-based implementation of it. But Windows is already tech preview now. I think Windows should be full support in OpenShift in 3.10 actually. Should be like this summer. But yeah, I think kind of managing like .NET Framework apps on Windows probably like a next year thing, honestly, at this point. Yeah. Really long answer. Any other questions? Shoot.
So, doing similar thing to orchestrate microservices and manage them. Do they implement similar
Which technology?
framework? Multisoft?
Okay. There have been a lot of I assume proprietary like other vendors. Like I know like
They would try to basically see the dashboard and
Yeah.
it's orchestrated somewhere and all it's not.
Yeah.
You don't know what they use. They use patches or whatever.
Most of the implementations I've seen that do that, like AppDynamics and New Relic and some of the other ones, a lot of them use code implementation. So if you're running like a Java app, you actually add like a jar file to your class path, and when your app starts up, everything goes through this jar before it starts forwarding, and then it takes all the requests and forwards on some central server. So I haven't really seen any other instances that use the proxy route. Everything is really embedded in code that like instruments your code and collects everything and sends it off to some other place. I'm not familiar with that one, but most of the like traditional ones have been around to kind of do the code instrumentation route of it, which works in OpenShift as well. You can manage those as a config map and other things. Istio is really built more from the ground up, specifically for the proxy implementation and specifically for microservices. So, yeah, some of those have pretty complex like middleware and other aspects to it as well.
How is Envoy deployed into?
Oh, good question. So, Envoy's. The question was how is Envoy deployed into the pod? So, Envoy is deployed as using the sidecar pattern. So every time you spin up an application as a pod, it spins it up. It spins a second container, an Envoy container, inside your app, so you don't even see it. If you're using Kube 1.9 or later, you can actually create an automatic initializer, which is really cool. So if you're just doing like OC new app, or if you're in Kubernetes and you're doing like kubectl create -f, it'll actually create. You can make it so that you don't have to do anything with the Istio CTL command line tooling. It just spins up the sidecar pattern for you. So if you noticed, like in the commands I was typing in the terminal, I was actually using the Istio CTL command line. I am using Kube 1.9, but I haven't set up like the admin piece to that yet. So I could log into the master and I could say, automatically inject these things if I wanted to. And if I have the permissions to do that, through the role-based access control, then every time I do, so say I'm the operations team for OpenShift and I want this to make sure this is going to be used everywhere, I can set that up. So anytime someone does source to image, or someone does a deploy of some other kind, a binary deploy, something like that, all these, the Envoy proxy gets injected as a sidecar pattern inside the same pod as your app. Yeah. There's other implementations too, like so Envoy is probably the one that's been the most tested with Istio. Linkerd is another one that's been around for a while. Linkerd, instead of having the sidecar pattern, implements the pod, or implements the proxy as more of a node-based. So everything on the same node uses the same proxy implementation, which there could be good use cases for that too, but you kind of limit it in terms of multi-tenancy and other things. So there's a few different implementations of it, but by default it's Envoy and it does a sidecar pattern. Any other questions? Shoot.
Still going through the services service. So
Yeah.
Working there, so still doing the load balancing within Kubernetes itself.
Yep.
You're then you're setting that down. So if you have 10 pods, each pod is doing their traffic manipulation independently of each other.
You can. So it's kind of.
What was the question?
Yeah. So the question was around kind of how does this work with, there's a little bit of a duplicative thing here between Kubernetes implementation of a service, and if you notice what I was using called a virtual service with inside Istio, kind of how does that work with service discovery? The other aspect is like the load balancing aspect to that as well. So everything in Istio plugs into Kubernetes service discovery, so it's going to talk to a Kubernetes service. And when you actually go to configure Istio, you're talking about managing between different Kubernetes services, but you can kind of override the Kubernetes like default load balancing if you want to do kind of like what I was doing with managing like the canary deployment of rolling up the traffic. So like in Kubernetes, by default, you're doing round robin between different pods in a service, and you can kind of override that and do more of a customized setting in Istio if you want to. But like the service discovery aspect is kind of plugs into the Kubernetes service discovery piece of it too. So like you're still talking, when you go to configure Istio, you're still doing like .service cluster local or whatever you're gonna have. There is some. The cool thing about Istio too is there is kind of a multi-cloud aspect of it too now. So if you remember Netflix, there was like that big Amazon outage a few years ago where the whole eastern seaboard of Amazon went out, but Netflix was still up because they had a lot of things built in to say, okay, well, if this service is down, I'm going to point to this service. And if this is down, those kind of things are built into Istio as well in terms of, and it's actually availability zone aware if you're in different public clouds as well. So you can kind of build that aspect of it into your application if you want as well for failover and those types of things. Any other questions? Cool. Well, thanks for coming. I appreciate it. I'll be out after if you have any more questions.